Here we are discussing about the triangle law, vector addition. Lecture 4. Here already draw four figures. In all four figures, figure 1, 2, 3 and 4. In this figure, figure 1, A and B is added, so resultant is given by the third side A plus B. Another case, this is A plus B. Here theta is an acute angle, but here theta is an obtuse angle. We here adopt a second approach for finding the modulus of A plus B. Actually, only the vector addition is a triangle law of addition. There is no any other addition for obtaining vector sum. If we recall the commonly sometime also known as parallelogram law of vector addition, polygon law of vector addition. Actually, all are not different addition. These are actually a vector addition, not a parallelogram law, and another laws are existing. But here not focus on that matter. Actually, here only focus on the basics of the calculation, mathematical calculation, and adapting another approach. Here we approaching that if we getting modulus of a vector A plus B, then we draw a perpendicular on this, and this is also perpendicular D. It is a vector A. Clearly, if CD is nothing but it is a mod of modulus of B. This is the cosine of the angle theta. But in this angle is pi minus theta. So here CD will be mod of B in terms of vector B, because we know vector A and vector B and the theta. The mod of B and the cosine of this angle pi minus theta means the minus. Actually, here it is a positive. Confused? No. Actually, it is a positive, because here theta is an obtuse angle. You see here in this second quadrant. So cosine will be already itself a negative. So this is the modulus, which is positive, and the minus. So whole thing will be positive. Here the expression is different from different, because here theta is an acute angle. So cos of theta will be positive. So CD will be positive. That is, if we write CD, means the length CD. The length CD will be mod of B cos of theta if theta is an acute angle, and if theta is on obtuse angle, so it will be mod of B cosine of theta with minus sign. Yes, both are the same if all the data in different figure is same. Now we want to find BD, length of BD. You see BD in figure 1 is greater than BC, and in figure 2 BD is less than BC. Clearly, if we write BD, if we write BD, BD is actually BC plus of CD due to figure 1, means if theta is an acute angle. According to this, BC is nothing but it has a magnitude equal to mod of A. We are actually here writing a geometrical length, but here we are writing a physical length, because if you add a constant both sides, this constant cancelled out. So directly we say mod of CD is nothing but mod of B and cosine of theta. Clearly, here you see that BD length is greater than mod of A, because here the sum of some quantity will be positive. So obviously this must be greater than modulus of A, which is true for figure 1. In figure 2, if we write in figure 2, you see here BD is actually BC minus of CD. For figure 2, that is if theta is an obtuse angle. Sorry, here I am missing 90 degree. Now BD is less than BC. In second case, you see if theta is an acute, CD will be written as minus of modulus of B cos of theta. This will be, and minus of this. This is the modulus of A. Clearly, the mod of A plus of the modulus of B in both the cases, the BD has an expression mod of A plus B cos of theta, but I warn that it is not here is the same, because BD in this case is greater than mod of the length A. In this case theta is an acute, so it is this plus and this plus, so it is greater than mod of A. But here BD is less than mod of A. Yes, this is greater than, because theta is an acute, so cos will be negative. So this will be negative. So this quantity is less than A. Yes, it is true of mathematics. Now, in figure 1 or 2 using, suppose 1 is taken, we know that AD in all the cases AD means this is AD. This AD will be actually nothing but modulus of B and sine of theta. Here theta is an acute, so this will be positive. In this case, this will be AD. In first case, you see mod of B sine of theta. Clearly, theta is less than 90 degree. And you see, if this will be sine of pi minus theta, if theta is an obtuse angle. Clearly, you here see that this will be again sine of theta. Here it is positive because theta in the second quadrant and the sine of the angle in the second quadrant will be positive. So, this is actually a magic of mathematics. Yes. Now, we know that by Pythagorean theorem, AD square of AD plus square of BD equal to a square of AB. Square of AD plus square of AD, and this is yes. This is nothing but modulus of A plus B in the square of this. This will be BD, means this is actually mod of A plus of mod of B and cos of theta. This will be in the square of this. This will be mod of B sine of theta and the square of this. If we are expanding and observing that mod of B is 2 into mod of A, mod of B, cos of theta, and modulus of B, this is square, but if we think this will be we write tan of alpha means this is the tan of alpha. So this length divided by this length. This length is mod of B sine theta, and also in this case mod of B sine of theta, and this in this case alpha is, so this will be mod of B sine of theta, and this will be modulus of A plus modulus of B cos of theta. So take expression for the tan of alpha. This is nothing but mod of B sine of theta divided by mod of plus mod of B cos of theta. This is an expression. Now on this figure 3 and 4, if we adding A and B, then resultant will be this. Theta is the angle between vector A and B, and alpha is the angle between vector A plus B and vector A. if vector B is shifting here parallelly and A is here, we get a case as in figure 4. Here a B is added A and a B plus A. Resultant is the same thing. Yes, here theta, it is pi minus theta. Okay, and this is equal to this in parallelogram law. Addition, you actually, here in parallelogram, vertically opposite angles are equal. So this, if this is pi minus theta, so this is also, so this is theta. Here you see clearly, here the vector A and here the vector B. Yes, theta is also the angle of vector A and B again here. So if we are moving along this is actually parallelogram, but it is not addition due to parallelogram law. It is due to, you see clearly here, it is due to triangle law. Here it is also. But so only we add a triangle law addition. There is no existence of parallelogram law, but if may you call parallelogram law, but not. You clearly observe in your minds and fix up it. It is due to parallelogram law, not due to, it is due to triangle law, not due to parallelogram law of addition. You see here another thing, A plus B is equal to B plus A. It is known as commutative law. That is A plus B equal to vector B plus A. This is commutative law. Now, if we are adding A, again we already draw two figures here. Suppose A, B and C are three vectors of the same kind. Here adding A plus B in two different situations. Here first A is added with B. This is A plus B. And you see here C is under added position with A plus B because its tail is on its head of A plus B. So this and these are in order. So this will be actually A plus B plus of C. So we write here, this is A plus B. First adding A plus then adding C. And second here B and C are first added because B vector and vector C are in order, so it will be B plus C. Now B plus C is in under added position situation, so vector A and this will be, so this will be A, then vector B plus C. You see clearly if all these two figures are same, you see here resultant is same. This is known as associative law. So A plus B then plus of C is A then B plus C. It is known as associative law. Actually, it is also known as polygon law or vector addition, because if I draw the three sides of tetragon, so resultant is given the fourth side taken in reverse order. If A, B, C are here we observe A, B, C are taken in order. Here also A, B, C are taken in order. So this will be resultant, it is reverse order than the rest of the vectors A, B and C. This is also known as polygon law vector addition. Here we actually remind you that and focus if a vector A, a vector this is a resultant of maybe any vectors this, or it in any of this, or this. So these vectors, after adding we get this vector. So these are called the components of vector this, and these are also the component of vector this. Here A, B, C are called the component of vector A plus B plus C. Here also A, B, C are called the components. Obviously A plus B is also the component of A plus B, vector A plus B plus a vector C, means this vector. That is all the vectors, this pair, this are the component of this and this are the component of this. So there are infinite number of component of vector this. Actually this is a polygon law vector addition. If the vector added taken in order, then the resultant is always in reverse order. This polygon law, this polygon may be a skew polygon, that is any of the vectors may be out of the plane of our page. Yes, such type of polygon is called skew polygon. Now if you shrink here gradually, arrow coming like this, you see here if A, B and this is C. Same kind, then resultant will be this. If it turn C as this position, see this position, C is this position, then resultant will be this. And if gradually shrinking C such that it become at this point, then this will be a closed polygon in which all the vector are in order. So clearly the resultant of this vector will be 0. You see here, if gradually shrink, then this will become a 0, means tends to 0 if gradually them shrink. Yes, this is A plus B plus of C will be 0. 0 means 0 vector. zero vector, which is zero magnitude, and direction is not defined of zero vectors. Now in next lecture we discuss about the vectors which has unit magnitude and the vectors of such vectors which are unit vectors. Thank you.